Hello everybody, this is Todd Frazee and this is the S60-141 CAD model for the base plate. This is a prismatic part. It has a whole bunch of hole features in it. So we're going to be using the hole wizard a lot in this tutorial to create the different patterns. So we have slip fit holes for press pins. We have a low tolerance press fit. We've got some threaded holes and some through holes for bolt clearance. So we got the whole gamut in this one. There's features on both sides of the part. So we want to make sure we get everything reflected that's in this. Alright, so if we look at our drawing, we are looking at the base plate and we have more complex hole callouts here. So, like for example, we have a 4 times 170 through with a 310 thousandths near side countersink at 82 degrees. So that's the head. But on the opposite side, it says unless otherwise specified, all holes have a countersink of plus 0.04 on its diameter at 90 degrees. So we need to make sure we put those far side countersinks in as well. Okay, this part is a 1018 steel, 1/4 inch thick nominally. And let's get started by just drawing the rectangular plate. Alright, so I'm going to minimize that. We are going to go to SolidWorks and we're going to create again a new file. Okay, and we're going to make that a part file, and as is my habit, I'm going to file save this as the part number S60-141. It's underscore rev 0 underscore T underscore Frazee. Remember, you're only allowed one mistake to get 10% knocked off, so just this naming convention is important. Okay, we're going to save that. Okay, so as we have been, we're going to make our planes visible. We're going to sketch on the front plane, and let's look at how our drawing's set up. All of the dimensions seem to be coming from the bottom, or most of them are coming from the left edge, bottom edge of the part. So we will draw a rectangle with origin at bottom left. And then we're going to put our dimensions on that. So accept the rectangle. We're going to go 4 inches in the horizontal axis and 3.5 in the vertical axis. So that's what our drawing says. We're going to go to a 3D view by holding the thumb wheel button down and moving the mouse. And we're going to accept our sketch, make sure it's highlighted. We're going to go to the Features tab, we're going to Extruded Base, and it's going to be 0.25 is our thickness. 1/4 of an inch. So there we have our main body piece. Now we're going to go back and study our drawing. So we have a whole bunch of holes, and so let's start with this 4 times 632 UNC 2A thread through. Actually, that callout's incorrect. That should be a 2B thread for an internal thread. I'll have to note that and up rev the drawing. So if you see B there, it's a different thread profile. Anyway, we're going to do that pattern. So what we're going to do is set up a sketch that has the center point of those 4 holes up front. So we've got from the left edge, it's 190 thousandths from the left edge, and then we have a distance from center, and then from the bottom it's 2 times 3/4 of an inch, and then we have a distance from the bottom. So let's go back to our model. we're going to sketch, and we're going to sketch on this top plane. And we'll look at the top here. Okay, so what I really need is 4 points. 1, 2, 3, 4 points. So we're just going to draw 4 points real quick, and we're going to start putting in dimensions. So from the bottom to this point, it was 0.75. And then from the left edge in, our distance was 0.19. We go from the point to the left edge, and we're going to put in 0.19. Okay, so this bottom hole, this hole on the right, is the same spacing from the bottom. So what we can do is we can put in, by holding the control key down, select both of those points and put a horizontal relationship between them. So that way those will always be in a line horizontally. Now likewise, this point here and this point here can be aligned vertically. So we don't have to double dimension those points. Alright, let's go back to our drawing, and where vertically is our other pattern. So it looks like it's 2 inches, and we have 2 of those, one location, one here and one here. Okay, so we're going to take and we're going to go 2 inches from this point to this point. Type in 2. And we can exit the dimension tool, and by holding the control key down, select the 2 points that are associated with that 2-inch dimension and make a horizontal relationship between those. Okay. Alright. Now we just need the spacing from right to left. So if we look at our drawing, the dimension between this hole and this hole is 3 inches 616 thousandths. So we're going to go from the first point to the second point. We're going to go 3 inches and 616 and accept. And then all we have left, if we exit the dimension command, is to hit control and touch those 2 corresponding points and make a vertical relationship between those. We should now have a fully constrained sketch, although it looks like my sketch is not. So I'm going to do a rebuild, and we're going to enter the sketch again, and the negative symbol's gone away. So it is now configured. Okay. All right. So I like to do one hole pattern at a time just to keep things clean. So we're going to reference those sketches, and we're going to put in our hole features using the hole wizard. So we go to Feature, Hole Wizard, and we're doing threaded holes in this case that are 4 times 632 UNC threads. So we're going to go and we're going to select threaded hole. It's ANSI inch. We're going to do a tapped hole. The size is 632, so it's a number 6 screw with 32 threads per inch. And the end condition is through all for both the hole and the thread. And we're going to put in, with thread callout, we'll include the thread class, which should have been 2B instead of 2A like the drawing says. And we need to make a near side countersink that's going to be 90 degrees, and it's 40 thousandths in diameter, bigger than the drill bit we're using. So we need to look up the major diameter of a number 6 screw. So we're going to go back to class page in Canvas. If you go to Home, and we're going to go to General Resources, we're going to go to the Machinery's Handbook, Or it works better if you've already got it downloaded. Okay, when we're returning to page, we should have covered this in a previous lesson, but we're at page 1817 in the Machinery's Handbook, and we're looking for the number 632 UNC, a 2A thread, and we're looking for the major diameter. So we're going to highlight this entire column, and we're going to go all the way over to major diameter, which is on the far right. And it's 138 thousandths. So we're going to add 40 thousandths to that number. 0.138 plus 0.04 gives us countersink diameter on both sides to have the lead in as specified. So let's go back to SolidWorks, and we're going to put in 0.178 as our near side countersink, and we're going to do a far side of the same size, 0.178. Okay, so now we have all our parameters input. We're going to go to positions, and we should be able to select on our plate, and then we select our locations and accept. Now the countersinks are going to appear a little bit large because of the fact that the thread is cutting into it, and graphically we're not showing the thread here. So they are going to look a little big, but that is the size chamfer called in the drawing, and it's by picking far side and near side, we've put them in both sides of the plate at the same time. So what you end up with should be a 20 thousandths chamfer in effect at 90 degrees on that whole pattern. Okay, make sure you're saving a lot. Now we're going to go on to our next hole pattern, and again we're going to lay out our sketch. Now our first sketch, some people will try to lay everything out in a single sketch, but I like to break them up so that you've got less dimensions you're dealing with, less chances of mistake. So I'm going to go ahead and make the sketch we just used invisible, and we're going to create a new sketch. Same plane, and we're going to look at that sketch in plane of material, and we're going to go back to our drawing and decide which is the next hole callout we're going to use. Let's do the 6th place dimension for the 1/8 inch slit fit pinholes. The reason being is the dimensions for that also provide the location for the clearance holes for the bolts. So we want to make sure that those are placed correctly. So we'll just do them in order of operation because the dimension calls out the smooth hole, and then the location of the bolt hole is taken from it. So we have 6 places, 1, 2, 3, 4, 5, 6. Now we have another 1/8 inch hole, but it's a loose tolerance one. It's this one. It doesn't require reaming. So whatever drill bit we go through to cut these other ones before they're reamed can probably do this hole. We just omit the reaming operation for that single hole there. That hole is a wire passage for wires to go into an electrical box. So it's not critical on its diameter. But we don't want to spend excessive machining time making that a super precise hole either. So because we have plus or minus 5 tolerance on that hole, whereas the pattern of 6 is a much tighter tolerance, has to be reamed. Okay, so here we go. We're gonna make our 6 locations, and on our model we're going to flip back to this drawing to get our dimensions. So alright, so we're going to go sketch, we're going to make some points. Okay, so we had 2 holes up here, we had 2 more holes up here, and then we had 2 holes somewhere in this vicinity. Okay, doesn't have to be that accurate with the placement because our dimensions will correct the locations. So let's exit the point command and let's put our dimension from the left edge to this first hole here. We're going to go from left edge to the first hole on the top. We're going to click, we'll go back to our drawing, and that dimension is here. It's 1 inch 100 thousandths. So we're typing 1.1 and we're going to accept that dimension. And we're going to exit dimensions, and this hole and this hole are in alignment horizontally. And this hole and this hole are also in alignment horizontally. And this hole and this hole are also in alignment horizontally with each other. So now we have those at least aligned. Now let's get our vertical edge for this first hole. Okay, so it's a add up of 217 and 669. Add that up. We have 217 plus 0.669 gives us 2 inches 839 thousandths. Okay, so we're going to Control C to copy that number. We're going to come in from the bottom. We're going to go to the point. We're going to click, and we should be able to go Control V, which gives us 2 inches 839 thousandths. Okay, so that gives us a vertical reference for those 2 holes. Now we need the spacing between the 2. Okay, drag up. We go back to our print. And the spacing in between them is 1/2 inch. 0.5. Alright, and that's to a tighter tolerance, so we're going to go 3 place decimals. We're going to actually check this one and go to 3 place on that one as well. Alright, so we have those 2 holes defined. Now let's go to the next set. Okay, so the position of these 2 holes is tolerance-wise is based off this first pattern. So if we take the dimension from the first hole here to the first hole in this pattern and drag to the left, we get the dimensional relationship between the 2. Okay, so this pattern can shift within this tolerance, but it's a little bit tighter between the 2. So we're going to go back and reference our drawing, and our drawing says it's 669 thousandths, okay, which is what I have in my default. And then we want to change that to 3 place decimal. Okay, now the dimension from side to side goes from that same first hole to the first hole in the other pattern. So we're going to click up, and our distance is 1 inch 299 thousandths. So okay, and then we have our distance between the 2 holes, which should be 1/2 inch. So 0.5 accept, but we're at 3 place decimals. And I forgot to change this one. Should be 3 place decimals also. Okay. There we go. We're going to accept. So now we just have these last 2 holes to do. So let's look at our drawing. And our dimension from the base at 875 thousandths. So we're going to go from the bottom of our part to the first hole, and that's 875 thousandths, which should move both of them. And we're going to go to 3 place decimals. Now from the left edge in, that hole is 380 thousandths. Okay, so it's 380 thousandths, and then we need the distance between the two. And we're placing that at 3 1/4 inches. 3.25. Okay, so we have our holes placed. We're fully constrained. We're going to accept that sketch. Now we're going to go to features and we're going to go to the hole wizard. And we're doing a plain hole this time, all the way through. We're doing ANSI inch. We're going to do dowel holes for an 1/8 inch. And we're going to make that dowel pin hole oversized. So our drawing is for a 126 to 127. To put it on nominal, we're going to make it 126 5/10. So we're going to go 126 in 5/10. It's going to be a through all end condition. Okay, and we're going to do a near side countersink that's 40 thousandths bigger in diameter than that. Okay, so we're going to take the 126.5, we're going to add 40 thousandths to it, so that's going to make it 0.1665. And we can apply that to the far and near side. And our degree is going to be 90 for our included angle. And our positions, we just pick our points. So I didn't quite get one of them, so I'm going to hover over till it hits coincident on that one. And then we'll hit accept. Alright, so we should have all our 1/8 inch holes for dowel pins in place. The one we're lacking is the loose tolerance one.